Transversal problems with equations level 1. Given m is parallel to n, find the value of x. So we have a set of parallel lines. This one is parallel to this one. We have 2x plus 29 for this angle and 6x minus 9 for this. So just as a quick overview, before when we talked about this, we have a total of 1, 2, 3, 4, 5, 6, 7, 8 angles, but really there's only 2 unique angles. Specifically, we would have an acute angle here and here. Notice those are vertical, and these would be acute. Then we could say that this one would be obtuse, this would be obtuse, this would be obtuse, and this would be obtuse. Another way you can look at it is you can use a transformation. What I could do is I could slide this angle right here up the transversal, and notice that those angles are not the same, but they do form a linear pair. What I mean by that is that if we took this acute angle and we added it to this obtuse angle, that the measure of the red angle and blue angle together would have to be equal to 180 degrees. And that's the approach I'm going to use. So let me clean this up, let me back things up, and I'm going to go ahead and write 2x plus 29 plus 6x minus 9 equals 180 degrees. And just to let you know, delta math will probably put parentheses in it here like this. Please notice that if you were to distribute a positive through it, we would just get rid of the first set of parentheses, and if you distribute a positive through 6x minus 9, it would drop the parentheses. So I'm just going to do that straight away. Alright, now we're going to use our 3-step process. I would have to distribute if the parentheses were there, like we distributed the positive. So that's taken care of. Now I'm going to combine like terms. I'm going to put 2x and 6x. Those are variable terms. Those are going to go together, and then the 29 and the negative 9 will also combine. But let's go ahead and draw our vertical line. Let's split our equation. Then 2x and 6x is 8x, and then 29 minus 9 leaves me with a positive 20. Bring down the equal, and then bring down the 180. So that was our first step, combine like terms. Step number 2 now is we're going to begin the process of solving. I would like to isolate 8x on the left side by removing the positive 20 by subtracting 20 on both sides of the equation. The positive 20, negative 20 will cancel, and we'll have 8x is equal to 160. And then we'll get rid of the coefficient of 8 by dividing by 8 on each side. And when I divide by 8 on each side, we have x is equal to 20. And that's it. I'm going to show you one more example where we don't have angles that are different. In other words, that they add up to 180. And I'll show you an example where they're actually the same. Okay, in our next example, we have given m is parallel to n. So parallel like that, and we have 6x minus 3 and 7x minus 24. Again, just consistent with what we've done before. These two are acute, and those are congruent by vertical angles, and these are acute and also vertical. We have an obtuse here, an obtuse here, and an obtuse here, and an obtuse here. So before we go any further, please notice that we have a blue angle and a blue angle. Those are congruent to each other. If you didn't want to look at it as acute and obtuse, what you could use is you could use a translation. You could slide this up here and notice that those are definitely vertical to each other. Or I guess if you wanted to, you could rotate this 180 degrees, and then notice that fit in there perfectly just like that. So however you want to look at it. In either case, the equations do not add up to 180, but they actually are equal to each other. So my equation would be 7x minus 24 is now equal to 6x minus 3. Let's draw our vertical line through the equal sign. And now we have a 3-step equation where we have a variable of 7x on one side, 6x on the other, negative 24 on the left, and negative 3 on the right. I usually like moving the smaller coefficients. Since 6 is smaller, I'm going to subtract 6x on each side. Again, you don't have to do it this way. This is just one of many ways. Again, as long as you use the properties of algebra, In other words, what you do to one side, you do to the other, it should balance out. So notice 7x minus 6x is just x, minus 24 equals the 6x, negative 6x cancels, and I have negative 3. Then I will isolate x by adding 24 on each side. And let's see, the negative positive 24 cancels. X is equal to negative 3 plus 24, which is 21. And there you have it. Now I do want to point out that if you had subtracted 7x on each side, you would have a negative x on this side. So then you'd have one more step of dividing by a negative 1. But again, either way, there you go. So you have an example where we're looking with transversal problems where you have angles that are supplementary. That means they add up to 180. And then you have an example where angles are actually equal to each other because they're congruent.